Happy Friday, everybody.
Happy Friday.
We got through everyone's presentation but mine last week, so I get to pull rank and, do it all by my lonesome today. But actually, part of what I want to talk about here, I think, has some interesting implications for certain things that we're working on right now, specifically with ISS, but more generally with other customers, dashboarding and timekeeping. So kind of two interesting vectors. So I do want for everyone to see this, and I want us to kind of get a common vernacular in our heads about how we're talking about and thinking about something that we like to not think about, which is time and timestamps and time math in systems. So, my topic, it's about time, an epic conversation about epics. Or is it an epic conversation about epochs? It turns out that depends on what side of the pond you're on.
Epoch. Epic. Epoch. Epic. Epoch. Epic. Epoch. Epic. Epoch. Epoch.
Yeah, I don't know.
I think my British lineage must be strong because I'm saying epoch.
It looks to me like it's spelled like epoch.
That's how I would have pronounced it.
So, why does this matter? What if we want to do something like this? What if we want to build a complicated set of charting where I can maybe grab a brush control, have that brush control update some other information, or maybe change the duration and have that update stuff, and have that information give me additional information. Look at what's happening at the top of that little tooltip, right? 22nd May, 30th May, 27th May, Medicaid remit, $1.687490 million, right? How does that work? Had I been giving this presentation last week, I would have riffed off of Rob's statement, it's not JavaScript, and said, it's JavaScript.
Right.
Because what we're looking at here is a web viewer running inside of FileMaker, running JavaScript charting, right? So in order to get this set up and functional, we have to provide a series of data arrays to this JavaScript. And JavaScript understands dates and times differently than FileMaker understands dates and times. FileMaker's sense of a timestamp kind of looks like I would expect a timestamp to look, right? If I say get current timestamp, and we evaluate that, that's basically what I think a timestamp should look like, right? Month, day, year, hour, minute, second, AM, PM, right? So FileMaker gives it to me this way, FileMaker presents it to me this way, except that's assuming that I'm in the US, right? If I was somewhere else in the world and I said, like any sane person, please put the day first so that it goes in sequential order, 22nd February 2020, well, then FileMaker would show it to me that way, right? Because what FileMaker's actually doing is it's giving it to me the way I told my system I wanted to see dates and times. But FileMaker's way of presenting timestamps looks natural and normal to us. JavaScript, not so much. Let's look at one of these arrays. Let's look at payroll cycles. That's not a huge one. It's got some big numbers, but it's not a huge one. This is what the payroll cycle array looks like. If I zoom in on that, it's a relatively simple construct, right? I called the object data7, and I've got a big old number here and an amount. So this is what a JavaScript timestamp looks like, right? So how do we make FileMaker play nice with JavaScript timestamps, and what other implications does that have? So what's a timestamp? A timestamp, simply put, combination of a date and a time. But if I was a child, I would say, well, what's a date? And I looked up, I went to Google and I said, what's a date? And I didn't like any of the answers that I found. So I decided to come up with my own definition. So I decided that a date was an intervallic indicator of the passage of time from some specific starting point. There's all kinds of dates in the world. We generally agree that our dates should be based on the Gregorian calendar, but that's again because of the part of the world that we're in, right? And the Gregorian calendar presents dates in years, months, and days. So when we agree that today's date is whatever today's date is, February, what was it, 21st? That's February 21st in a specific year, right? In the year 2020. And in our modern secular society, it's the year 2020 Common Era. It started out as the year 2020 after Jesus, except we kind of got it wrong because Jesus wasn't actually born on year 0, generally accepted that he was born about year -4. And, you know, so it's no longer AD, it's now Common Era, right? But still, most of the Western world, year, month, day, since that year 0 point. But time, life didn't start at that year 0, right? It went way earlier than that. But nonetheless, we count from that point, that arbitrary point, 2,020 years ago. What's time then? A time is an intervallic indicator of the passage of time from a daily starting point, right? But it's a cyclical, meaning it resets, right? So every day, time resets from a 0 point. And time is presented in hours, minutes, and seconds. So we divide our day into hours, minutes, and seconds for time. And then a day equals a fixed number of hours and minutes and seconds. Except not really, because we have to fix it every now and then because it gets off, right? We lose a second here and there, gain a second here and there, add a day every 4 years, you know. But usually in 8 days. So how do computers calculate time? This is kind of stating the obvious to this crowd, but I think it's important to recognize the details here before we get into what do we do about it. So it's really pretty simple. Dates and times are simply numbers. They're a count, right? They're a count of some interval from some point to some other point. So dates, what's our lowest common denominator? Simple, it's a day. Right? So if we're going to calculate a date, what's the number from here to there? Number of days from here to there. That's how a computer thinks about it. For time, what is it? What's our lowest common denominator? It's a second. So how many seconds from here to there? Now, some timestamps have higher resolution. They might have a millisecond resolution, which is 1,000th of a second, or they might even have a higher resolution than that, right? But for all computers, it's a number of x from some arbitrary point to some other arbitrary point. If we ask FileMaker, get current timestamp, the answer is going to be to the arbitrary point of our computer's clock sync as of the moment we hit that evaluate button plus however many microseconds it took for the computer to actually compute and display the result, right? So, what time is it? FileMaker believes in the Gregorian calendar. FileMaker starts on 111000. It's nice and simple and straightforward. And it formats its timestamps by default American style. MMDD, YYYY, HHMMSS, right? But most computers don't. Most computers believe that Earth began on 1970, 000. And kind of the generally accepted way of formatting a timestamp is the way you would want to if you wanted to use something where we've got our alphanumeric sequence that sorts properly regardless of our data storage type, right? So we put the biggest thing first and the smallest thing last. Kind of makes sense, right? So a standard ISO timestamp is YYYY-MM-DD hour, minute, second. Notice no AM, PM. It's the divider between the date and the time.
Okay.
Notice no AM, PM, because what is AM, PM to a computer? It's nothing, right? It's an artificial construct meant to help us know whether the sun is past its zenith or not in whatever particular time zone we're in. In both cases, there's 86,400 seconds in a day, right? Which is 24 hours times 60 minutes times 60 seconds. So, how can we coordinate all of this? There's this thing called UTC. What does UTC stand for? Anybody know? Close. Coordinated universal time. It is not universal time coordinated. It is coordinated universal time.
So it's really cut.
It is really cut, but somebody decided cut didn't make sense.
Right.
So, it's important to understand that UTC is not a time zone. There is no spot in the world that has time thought of as UTC. UTC is a worldwide standard. It is an agreed upon worldwide standard that is actually maintained on two different fronts. It's maintained with a whole series of nuclear clocks that link themselves to the solar cycle, and it's maintained with a series of bodies of scientists and philosophers, I suppose, right, who agree on this is the real deal, this is the thing. But importantly, doesn't shift for daylight saving time. And all of our computer clocks, every modern computer clock in the world is synchronized to UTC. We don't read our time in UTC, but every single modern computer clock is synchronized multiple times a day to UTC. So why do we care about that? Well, we care about that because as human beings, we don't like UTC. UTC doesn't help us. It doesn't tell us when to get up. It doesn't tell us when to go to bed. It doesn't tell us when to be on time for a meeting. It doesn't tell us any of these things. And we have all of these special accommodations that we make for ourselves. For time zones, because, you know, I don't like thinking of it as noon when it's pitch black outside. So I live in the Central Standard Time Zone, except then we get to the summertime and now I live in the Central Daylight Time Zone because somebody thought that was a good idea. Your computer knows UTC, and your computer knows what time zone you're in and knows whether it's daylight saving time or not. Most of the time, every now and then we have to ship a patch to fix it up. because it keeps changing. When is daylight saving time and all of these things? But a modern computer, 2020 computing device, knows these things. So your computer can easily calculate the offset between local and UTC. Why does that matter? That matters because if you want to write a JavaScript timestamp, or in fact, if you want to interact with most things in the world on a computer via an API, you need to use UTC. But if you're using UTC and you want to do something friendly like show me when I actually clicked start time block or clicked stop time block, I need to be able to convert back and forth, right? I need to be able to show it in the logical local time. Matt's not in Central Time right now. Matt's in Mountain Time. And Matt sent an email to Hav this week saying, I click this button and it doesn't show the right time. Because it was still showing him Central Time. He wasn't in Central Time, right? So as we think about building systems where our system is larger than something that will only ever exist in one building, ever, 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 we need to start thinking about recording our time in UTC, right? Our time of record should be in UTC, should not be in who knows whatever time zone it was in at the time that it might have happened, because there's no way to reconstruct that properly after the fact. No way. So, RTK, not built with UTC, but it should be. Whatever we do with eTime should be UTC on the back end, right? So, I decided, hey, I want to solve this problem, and I want to solve it in an elegant way. I did what any self-respecting FileMaker developer does, and I went and I Google searched for who had solved it previously, right?
I have it. Because I did the same thing.
And the answer turned out to be a variety of sort of maybes, kind ofs, and answers that I didn't think were particularly elegant. I didn't like any of the solutions that I found. Because what is a JavaScript timestamp? It turns out a JavaScript timestamp is a Unix or epoch timestamp in milliseconds, right? So why do all of these numbers here have 4 zeros at the end? Well, they have 4 zeros at the end because they're all millisecond timestamps. If I were to rip off those 4 zeros, I'd have a normal Unix timestamp. But they're also in UTC. Always, only, ever in UTC. So for this graph to draw right and it to put these bubbles in the right spot on the right day, JavaScript is doing the job of knowing what that timestamp is in real day terms. It's also doing the job of presenting it to me interfaced with my local time and date. I don't have to do any of that. I don't have to code any of that. All I have to do is give it a properly formatted JavaScript timestamp, which is a UTC timestamp in milliseconds. So how do we get there? FileMaker actually has some nice tools. It is not, I would say, historically as rich in time manipulation tools as some other languages, but it has quite a number of them, starting with get current timestamp, right? And get host timestamp. That helps a little bit, right? Then we know that everybody's synced to what the host thinks it is. But let's just start with get current timestamp, right? There's that timestamp we saw before. But how do we tell FileMaker what timestamp it is? Well, so if I just type in, let me blow this up a little bit. If I just type in timestamp, well, all I have to do is give FileMaker a date and a time. Well, that's cool, okay. So if I type in date and time, all I have to do is give FileMaker a month, a day, a year, hours, minutes, seconds. So let's double check what FileMaker's doing here, right? Let's go month 1, day 1, year 1, hours, 0, minutes, 0, seconds, 0, right? And for comparison, I'm going to zoom back out so I have my controls for a second. Let's do a little return. And let's do a get as a number, get current timestamp, right? And what does get as number do for me with a FileMaker timestamp, any of my FileMaker developers?
That's going to give you the number
The
of
numeric
days
value.
since the first day of the calendar and the number of seconds since the beginning of the day.
Right, so if I do it actually as a timestamp, it's just going to give me the number of seconds for the timestamp from 111000.
Okay.
Just seconds. Timestamp is a combined second. So, there's my 2 answers, right? Why do I get that answer? I get that answer because in the first line, I said, give me the number of the timestamp 111000. Wow. What was the number 1 second after Jesus was born, assuming Jesus had been born on 111000? The number was 1. Crazy. What was the number 1 minute after? The number was 60. What was the number 1 hour after? 3600, right? What was the number? Oops, that was 1 year. See, I'm being American again. Month, day. Thank you, Heather. Second one. 1 day after, 86,400, right? So we can see how FileMaker timestamp stuff works. Pretty straightforward. And this number here at the bottom, that's the number of seconds since 111000 as of the last time I clicked that evaluate button. All right, so that's cool. But how do I reconcile Gregorian time and Unix time? Well, we have to be able to calculate what is Unix time, right? What is Unix? I just figured out how to calculate FileMaker Genesis, right? FileMaker believes the Earth began, or at least the part of the Earth it cares about, began then. When does Unix think the Earth began? Unix thinks the Earth began there. So that's the timestamp for Unix Genesis. So how do I turn a FileMaker timestamp into a Unix timestamp? It's easy. It's just math. I go take my timestamp, right, get current timestamp, and we get that as a number because we'll get really funky results if we don't. And if I subtract that Unix Genesis, I get a number that looks very suspiciously like those other numbers I was showing you. And in fact, I could take this number and I could go to one of a million websites out there and I could stick it in there and I could click that button and it would validate for me that in fact that number was right. But that's not UTC yet. That's just a number. There's nothing specific about that number as being here. Or UTC, it's just a number. So how do we get to UTC? Well, historically, and this is what I didn't like about a lot of the solutions out there, they said, well, just figure out what your offset is and then add that to your math. Oh, well, that's a bunch of sucky work. I don't want to have to do that. I want it to always be right. Always, always, always. So FileMaker has given us this neat new thing in the last few versions. And if I put in time, it's hanging out down there at the bottom. get current time UTC milliseconds. That's cool. So it turns out FileMaker can tell me what the current millisecond is in UTC. Now we use this all the time lately if we want to time something, right? How long did this script take? We used to do that, and I used to go, woo, it took 0 seconds. No script takes 0 seconds, right? Now I can go end UTC milliseconds minus start UTC milliseconds and go, oh, it took 462 milliseconds, which rounds to 0, right? But I know how long it actually took. Well, to a resolution of milliseconds, which is 1,000th of a second. But that's pretty good, usually, right? So I've used it for that all the time. What I hadn't thought of doing is going, can this help me automatically always know what time it is in UTC? And it turns out the answer is sure it can, right? Because what can we do? We can turn this into a timestamp, right? How would we do that? Well, to start with, timestamps aren't in milliseconds. They're in seconds, right? So if I give FileMaker this number, if I say get as timestamp as is, what is it going to do? It's going to go, as not a timestamp I recognize. But if I say, oh, that's right, FileMaker doesn't do millisecond timestamps, it's going to go, oh, I know what that is. Sure enough, I know exactly what that is. And it even did me the favor of adding a decimal point, right? 0.173. It's 53.173 seconds. Very accurate. But note that it's 6 p.m. Why is it 6 p.m.? Well, because UTC time is 6 p.m. right now. It's not noon right now. But it's noon right now here. I know that because my watch tells me that. My computer tells me that. Well, that's kind of cool. So that must mean that I can figure out what the difference is, right? I can figure out what the offset is. So if we don't get it as a timestamp, if we just kind of keep it as a number, and then we use the magic of math to say, let's get as number, get current timestamp. And of course, we could construct a timestamp, but let's just do right now. And I go minus. Oh, interesting, right? I don't really care about this part. That part's probably not helping me. I bet FileMaker has a function that would make that nice. Ah, I don't know how to read that though. Oh, isn't that neat? So the cool thing is, let's leave that there, and let's fly somewhere. Where is?
Bottom middle.
Thank you, Robert. Let's unlock this thing and say, no, I really don't want your automatic notion of where we are in the world. We are going to go to the heart of Africa, Burundi. Let's see. It's 8:10 p.m. in Burundi right now. Huh, cool. I know how to get back to UTC. Let's go to South Central Australia. Broken Hill, as it turns out. Probably not a very populated place. But, 10:30 a.m., it's also tomorrow. Ah, that's magic. Wow.
Time travel.
Right? But I know how to get back
Quick check the
to,
numbers of tonight's lottery drawing.
I know how to get back to UTC. And it can become daylight saving time in my part of the world, even though it might not yet be daylight saving time or might have already been daylight saving time in another part of the world, and it's always automatically going to get it right. So I can build a function to do that, right? And what's that function going to look like? That's not the one. That's not the one. It's one of these. This is what you get for not letting me give this last week. I had this all prepared. The function can be pretty simple, right? It can be, I need an offset, right? So I need to figure out the difference between UTC and me. I need to give it a timestamp. In this case, we're getting the current timestamp. I need to figure out what Unix genesis is. I can therefore figure out what Unix time UTC is, which is timestamp minus Unix genesis plus offset, and I can turn it into milliseconds, right? So I can get my JavaScript timestamp, and it will always be perfectly always accurate for a conversion of FileMaker timestamp to JavaScript timestamp wherever I am in the world. So a nice, simple, straightforward 3-line custom function. Right? Let's just do that. So
although UTC is not a time zone, in effect it is tied to a time zone.
So Heather said, although UTC is not a time zone, in effect it is tied to a time zone. UTC is at various times of the year similar to GMT, but it is not GMT. If GMT is choosing to follow daylight saving time, then UTC is not GMT. So yeah, there are moments in the world where UTC aligns with someone's time with zero offset, right? But it is not a time zone. So, everybody a UTC convert? We're all going to use UTC from now on in the heart of our systems. Heather asked, once we have UTC time, what is the calculation to convert UTC time to human readable time? I didn't actually build that, but it would just be the same function, only flip the offset the other way, right? So, and by the same token, if we started with a JavaScript or a Unix timestamp, we could do the same thing. We could convert it to a FileMaker timestamp by adding back the difference between FileMaker Genesis and Unix Genesis instead of taking it away, right? So, haven't built that function, but it's really just the opposite of the function I did build.
If we get a timestamp from some other source, is there a standard where we know that this is UTC versus this is a very long number that's not necessarily UTC?
That's a good question. Who maybe knows that? In my mind, I just kind of look at it and say, does that look like a Unix timestamp? Unix is pretty ubiquitous. Unix or epoch time is pretty ubiquitous.
I mean, usually it'll be in the API documentation if you're using an API.
Right.
It'll say, hey, here's how we're using our timestamps. In my experience, that's just reading documentation. And hopefully it's complete and accurate.
Certainly,
it's not always.
Certainly a quick and easy way to find out is to grab something and click it into something and say, is this correct? Is this correct, right? And so it's currently saying it's 4:45 a.m. in our time zone, but let's go back home and reevaluate that and get a new number and go over here and paste it in. That looks right, right? So, you know, we could take, if we know what the timestamp is, we could just drop it into some Googleable calendar and find out, is that what it is, right? Does that work out properly?
The math on a UTC would only go back 50 years.
Unless it's a minus number.
Right.
Yeah, I mean, that's how, for any UTC or Unix timestamp, the way we calculate something before Unix Genesis, before Unix Jesus happened,
Right.
is a minus number, right? And it's the
Right.
same thing for FileMaker, right? The way we get to something pre-AD or BCE, whatever language you want to use, is a minus number.
I think like another good tool would be like a lot of the APIs and a lot of the services that you use before you're sending time to FileMaker. There's usually a method that'll convert it to a UTC string. So for always sending in that UTC, then we can have FileMaker doing that conversion. So it'll be like standard.
Yeah. Yeah, and I think that's where I'm getting at. If we start making a habit of always recording time as UTC, if that time matters, and we record it as UTC and then convert it out, then we'll always know what it is, right? We're essentially removing the locale and the daylight saving time component from it, right? So we always know exactly when it actually was, not essentially a recording of when it was where we have to know what computer recorded that and where was that computer at the moment that it recorded it, right? Because that's the way our timestamps work today, right? When someone in ISS does a thing, we only can figure out when, on a nuclear clock, when it really happened if we happen to know they did that thing in the state of New York to a clock linked to Eastern Standard or Eastern Daylight Time when they did it.
So in the example of ISS, we use host timestamp and an audit trail. There's an assumption that the host timestamp is accurate.
There is. But what if the host is in Oregon?
Right. So if the host is in Oregon, then this should, with the calculation that you put together, that should still work accurately. But what if the local clock is wrong?
The one assumption we're making is that whatever machine we're on has its clock synced and is aware of its time zone and its date, thus daylight saving status.
Right.
Right? So if its clock is off by a minute, our timestamp will still be off by that minute. But it won't be off by an hour or 2 hours or whatever because we made an invalid assumption
Right.
about daylight saving time status or time zone status. And any modern computer that is NTP time synced knows what time it is, knows what daylight saving status it is, and knows what time zone it's in.
Right.
Right?
So one of the things that we do in ISS is we have one audit trail that is an audit of status in Expense 2.0, where we track every time that the status has been changed, we capture certain information. We capture it in JSON. And originally, the node that all the detail was in was based on the host timestamp. At a point in time, we decided that doesn't work because JSON's sorted alphabetically by FileMaker when you format it. So we ripped through and replaced all of the FileMaker timestamps with a different format, which wasn't UTC, but it was year, month, day time.
Kind of ISO style.
Sort of,
Yeah.
right. So that things appear in the order of how
Yep.
they occurred, right? But if we converted that to UTC, obviously we'd still need a human readable version of that time. But alphabetically, in the sort, it would still end up the way that we want it to. Is
Sure
that
would.
correct? Right.
Sure would.
Okay.
Yeah, until we go from, trillions to tens of trillions of seconds or whatever the, I haven't counted how many digits there are, but yes, sure would.
So when it comes to the throwing all that stuff into the web viewer there with the JavaScript code and doing all the cool fancy things, so the JavaScript is displaying to you July 19, so on and so forth. So it's displaying to you the correct date. Right? So if that person in Broken Hill, Australia is looking at this same thing with the same data, are they going to see different dates because the JavaScript says, oh, your computer is a different time zone, so you're actually tomorrow UTC time, but based on, like, if they're looking at the same data point, would it say May 23rd for you and May 24th for them?
Great question. I think what the answer to that comes down to the kind of data we're looking at. In this case, we're looking at historical data that happened at a particular point in time. And in order to get those bubbles to not sit on top of each other, I actually artificially created the time that they occurred at, right? So I put an hour between each bubble, figuring I would have less than 24 events in a day, right? So in this case, I have events that happen at 1 a.m. and 2 a.m. and 3 a.m. and 4 a.m. and 5 a.m. because it turns out that this particular charting class, if I put two events at exactly the same time, it adds them together. It doesn't show me both of them. It merges them into a single data point, which completely corrupted what I was trying to do, right? So I used the timestamp to my advantage to artificially set them at 1 a.m., 2 a.m., 3 a.m., 4 a.m. Now, because the way this chart is working, there's nothing that is going to cause it to say exactly when that's at, other than my computer's notion of what time it is. So I think the answer is yes, it would look slightly different to someone there, but I don't think it matters for this kind of data. Where I do think it matters is if we were talking real-time charting, right? So if we're doing a real-time dashboard and we've got a ticker going along, exactly what I would expect to see is if I'm watching the ticker here in Dallas and somebody's watching the ticker over in Germany, I would expect to have it showing to me in my now time, right? And I would expect it to be showing to the person in Germany in their now time, which would be like 7 p.m. right now, right? Whereas right now it would be noon, when in fact it's happening in New York at 1 p.m., right? But we should all be seeing that ticker with a time increment that is our now time, because that's how we're thinking of it, right? So I think it gets to what are we trying to present with the data as to whether we want the actual UTC instance of it or the when was that where I am in the world instance of
Okay,
it.
so in the example of a birth time, the baby's born at, midnight in California. Well, not midnight. They're born at 10 p.m. in California on January 1st. It's already January 2nd in Australia. But at that point in time that the baby was born, well, it's recorded as January 1st because that's where it happened. It happened on January 2nd in Australia.
It did.
At that same moment. So the fact that you're
Pick your own birthday.
Right. So if you were looking at this, where I was seeing a potential issue was if you're looking at a chart where you've got dates of these things happened on this date, but it happened on the 1st of the month in New York, it happened on the 2nd of the month in Australia. The fact is, in Australia, had that been where it happened, it was the 2nd
Right.
when that happened, right?
Right.
Okay.
True. So I think to take that one step further, this might be why we also want to record a geostamp with an event, Because if it matters that we're able to say the reason this child's birthday is the 1st is because of where they were in the world when it occurred.
Right.
Then we need the geostamp
Right.
to go along with it to be able to reconstruct that after the fact.
They didn't have geostamps in 1970.
They sure didn't, but they had these things they wrote on documents that were like counties
Yeah.
and cities and states.
Would a geostamp be enough?
Well, it would be enough to, if the geostamp meant the location of this event that we just timestamped, UTC, occurred here, then the geocode would be enough for us to reconstruct what was the local time at the event, right? Where that event occurred, what time did those people think on that day it was, right? I mean, that's what the geostamp gives us.
Yeah, because one thing I can think of is in practical use is like with you and Randy with y'all's Dexcom, it gives me the data whenever I'm pulling it into UTC. Say we are here in Dallas and we all go on vacation to Australia, then now it's going to be reading in that time. And then we come back and we want to look at our historical data because the doctors asked for it. We don't want to have 2 days for the 24th and no days for the 23rd.
Right, yeah. Somehow I had 2 readings at once. How did that work?
But I'm missing a whole day.
So the fact that it could be 2 separate days in local time is the entire reason for UTC existing, right? When communicating to people across the pond or whatever, it does help to, if possible, communicate with UTC because then, well, it's, it's February 21st, 12 p.m. UTC. Then in their mind, they can sort of construct when exactly that is. But to the point of the birthday thing, well, yeah, the geocode is important because then locality matters, but in a lot of cases, locality doesn't matter. And that's why we would communicate in UTC.
Yeah, because if it was a universal event, like a server recording something at a moment, locality is irrelevant. The server anymore is so unlikely to be where the person who cares about that event is located. Locality doesn't matter. The geostamp doesn't matter. What matters is that we know, sans the constructs of time zones and daylight saving time, when actually was it, right? So let's stop there. Yep, no?
Yeah, real quick, I just wanted to...
Okay. One more thing. Hav has the last word.
Yeah, I just wanted to elaborate on one thing. So in our systems, in our databases and stuff, if we're storing the UTC time, then we have the power of controlling how that data is presented, right? So on an application level, let's say it's an application where that person needs to be able to see that time in their local time. We can convert that UTC time and base it off of wherever their device says they're located. But let's say for example, it's something that we want to show like only New York time, right? Like let's say the example of children being born, right? Based on children in New York being born. We can hard code that application to convert that UTC time into New York's time, let's say per se. So that way you always have the correct time on a universal basis, and then you present it like how you want and have that control in your application.
Yep.
Yeah.
All right. Thank you all. I have foods here.